Well, good afternoon, and thank you for giving me this opportunity to present at the Transportation Infrastructure Durability Conference. My name is Stephen Nolan. I'm with the Florida Department of Transportation in the State Structures Design Office, and I'm primarily involved with coordinating implementation of FRP composites for structural applications, along with some other corrosion-resistant technologies. Today I'm going to step through Florida Department of Transportation's experience with structural composites, look at the different types of composites that we're interested in, those that we've researched, implementation to date, and then some typical example projects, some photos with some eye candy, and then some thoughts on what we might need for broadening the deployment and scaling up the application of composites. The primary motivation for Florida to consider FRP structural composites is related to corrosion and durability. Florida being a coastal state, similar to Maine, we have a large coastline, heavily developed, and a lot of infrastructure close to that coastline. So we're looking at saltwater applications, either within or above, or very close in proximity, and so that's a primary motivation. There are some potential benefits to composites in their lightweight and unique formability, and so hopefully we'll be able to take advantage of some of those in the future, but and the motivation for now is primarily durability of our foundations. Looking at different types of structural composites that we've used to date, for pre-stressing, it's limited to carbon pre-stressing cable for internal reinforcement. We have not done any demonstration on cable stays like you have up there in Maine. We have looked at some in collaboration with university alternate pre-stressing materials way back in the past with Aramid, but more recently with the lower strength GFRP and BFRP materials. So there's some potential there in the future for light pre-stress applications. The major use currently is with internal reinforcing bar, reinforced concrete, and primarily with glass GFRP rebar, since that has been standardized under the ASTM D7957. We've also done some research durability and strength-wise with basalt FRP rebar, and we're confident we can implement that at a similar level as the GFRP, so we have developed specifications for that. Carbon bar, due to the cost and the higher mechanical properties, has primarily been limited to near-surface mount applications for rehabilitation. Then looking at FRP structural members and systems. Fender systems is probably the main use for FRP composites for Florida at the moment. Those are both thermoplastic and thermoset type structures, relatively sacrificial, so not quite the same level of risk as a full-size bridge. I recognize that, but far superior to timber systems that we have traditionally used. There are also many hollow profiles available for structural profiles that can be used for boardwalk structures and pedestrian bridges, and we've seen some of that utilization around the nation. Very limited application at this point in Florida, but something of interest. And then the composite FRP girders is an emerging technology, and there's been a few projects up in Maine that have successfully utilized that, and there's some interest from some local areas and local agencies down in Florida for other applications. We're currently looking at how to best procure those systems on a competitive basis at Florida DOT. So we're still working through some of those systems, but that's a goal to be able to consider those systems in the near future. And then the concrete filled FRP tubes, formerly a bridge in the backpack. There was one of those recently built well, not recently, but a few years ago, down in Southwest Florida, and perhaps Ken Sweeney will talk about that one as well in his presentation. Can't talk about FRP structural reinforcement without strengthening and repair, since that is our primary application for rehabilitation, especially when we have overside truck impacts and significant damage to our pre-stressed girders, or significant corrosion for our low-level overwater structures. Looking at some of the research, just touching on the scope that we've addressed in the past and currently looking at. We started out looking at marine pile systems, obviously, and we ended up there about 20 years later with a completed system. We've also looked at several composite rehabilitation systems in the 1990s, and then more recently we looked at the durability of some of those old rehabilitation systems, repair systems, with relatively good success. So that gives us more confidence moving forward to continue using those systems, perhaps for even a longer service life. And then we've also been looking at novel applications of FRP reinforcement for, let's say, extending the usefulness of our current pre-stress piling with GFRP spirals instead of the traditional, well, not traditional, but what we currently specify is carbon spirals due to the high stiffness. Whether that actually becomes feasible, we'll find out in the next year or so. And then we've also developed some protocols for testing of GFRP reinforced railing with a pendulum system down in Florida, and then an epoxy dowel GFRP splice for our pre-stress piling when you have need to splice those concrete piles in construction. So those are just highlights of some of the more recent projects. You can see a full list of those at the website on the previous slide. So just reiterating the process that we've gone through over the years, primarily focused on rehabilitation and strengthening and repair, then the fender systems, and then internal reinforcement with some novel rebar, basalt rebar, which was a relatively new fiber to the West in the last 2 decades. And so 2014, a demonstration of 2 sections of retaining wall were built down in the Port of Miami, and those are still functioning well. Not far away, the University of Miami did some novel pre-stressed double T pedestrian bridges with a number of different FRP type reinforcing systems, basalt and glass, for the substructure support. And the largest project we've most extensive use of the different kinds of structural composites was the Halls River Bridge, built primarily between 2017 and 19. And that one featured the hybrid composite beam, which I believe had some work done at the University of Maine, and then pre-stressing strands in the piles, bridge bearing piles, and the concrete sheet piles for the bulkhead retaining walls, and then reinforcing bars in the caps for the pile bents and the decks and traffic railings. Moving forward, we have just completed a couple of vehicular bridges with GFRP reinforced concrete decks, 2 and 3 span cast in place flat slabs, along with different kinds of abutment protection using soldier piles with precast concrete panels with GFRP reinforcement. So as I mentioned earlier, durability is the primary reason for considering FRP composites. There may be some structural advantages due to the lightweight. There might also be some advantages in coupling FRP with other technologies, such as lightweight or ultra high performance concrete, or and then the last one there, that high strength stainless steel pre-stressing strand is really a competitive system that we're currently allowing to compete against the carbon fiber cable for pre-stressed piles, and shall be implementing for pre-stressed beams as well. To provide this information to our design community, we've developed these web pages for jumping off points where you can find a lot of information related to both design, construction, material acceptance, and example project applications. We don't only have FRP materials there, as you can see in the two red boxes. There's some similar competing corrosion resistant materials related to ultra high performance concrete, and we'll be launching one for stainless steel in the near future as well. So drilling down into a couple of those web pages, we have one on FRP reinforcing, including strand, and then another on FRP members and structures. That one is a little newer and is still being developed, so we have some expectations in the future that we'll have more projects available on that one. But you're welcome to go out to our website and take a look at the content on there. It provides links to our structures manual. Volume 4 is our primary source for design, and then our construction specifications have various sections that relate to FRP that have been developed. And on the manufacturer's side, we don't do a approved products list for FRP. We have approved manufacturers or production facilities, and there's a fairly robust system set up in the state by the State Materials Office in their materials manual, and then you're able to access the currently approved producers on this system called MAC. And on the next slide, we'll just show you some of the producers that are currently available. We have about 8 related to FRP rebar and strand, and then a few related to structural members, primarily fender systems, but also sheet piles and protruded shapes. Looking at some example projects, we have a number of different projects primarily related to reinforced and pre-stressed concrete, soldier piles with precast panel systems. We did some secant piles, which are essentially auger cast overlapping piles for a coastal seawall, and then our first pre-stressed CFRP bridge slab system as a replacement down in the Keys. We did a number of pre-stressed concrete sheet piles, starting out with Halls River Bridge, which also utilized the hybrid composite beams as a superstructure system, and then just our go-to polymeric fender systems for our navigational waterway channels. On those web pages, there is a projects tab which has fast fact sheets for a number of example projects, just 2-page sheets that give the highlights of each project. So I encourage you to go and look at those for more details. We have various examples on the page here related to Halls River Bridge, and then the Flagler Beach Seawall project, Port of Miami Tunnel. Several projects just recently completed for cast in place GFRP slab bridges, and always doing more seawalls and fender systems. A number of projects in final design or letting and to be constructed in the next few years, so keep an eye out for those. And then looking at what we really need for scaling deployment for broader application. Florida being a growth state, We want to keep our existing system in a good state of repair, so as it expands, we don't have escalating maintenance costs. So just some thoughts on implementation. We really need a way for cost justification, because a lot of these systems are more expensive up front. May not always be the case, but we need a competitive bidding system to evaluate, for the contractor, evaluate one structural system against perhaps a more conventional system, and how you weight those is something would need to be identified if first cost is not your primary selection. And then standardization of specifications and standard drawings is always helpful to point everybody in the same direction. Potentially harmonization of design codes, at least within the US and maybe North America and eventually beyond. And then devil's always in the details, so improvement of design detailing for our designers and getting that information shared. So there's a number of things. Software is also very useful and builds a lot of confidence with engineering designers. On the manufacturing side, I won't go into detail on those, but those are some things that can be explored as well. And so that's all I really have time for. I think I went over a little bit, but sorry about that. And hopefully there'll be some chance to answer questions during the panel session. Thank you.